Hello everyone, this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the leftmost derivation and rightmost derivation. So till now we have seen that the context-free grammar and what is meant by context-free languages and how to form a grammar from the context finite automata. So we have already discussed about the context-free grammars and now we will discuss about the leftmost derivation and rightmost derivation. So before going to this leftmost derivation and rightmost derivation, we have to know that what is meant by derivation. So derivation is a sequence of production rules. So what is meant by production rules? We already discussed in the grammar. We have the production rules. So with that production rules, we will form a string. So here the derivation is a sequence of production rules. It is used to get the input string through these production rules. So why you are going for the derivation in the sense, because of these production rules, we can form a strings, input string. And during the passing, we have two decisions. These are all as follows. So what is the two decisions in the sense? We have to derive a string from the production rules. We have to do the two steps. What are those in the sense? We have to decide the non-terminal. So non-terminal is nothing but, so let me write the grammar. Z is equal to V, T, P and S. So here V is nothing but it is a non-terminal, so which is equivalent to a finite automata, finite set of states, and those are represented in the capital letters. And T is nothing but it is a terminal, so which are represented in the small letters, so which are in finite automata, which are belongs to the input symbol, that is a sigma. And P is nothing but production rules. So with the combinations of terminals and non-terminals, we will have the production rules. And S is the start symbol. So this is the grammar tuple. So it is having the 4 tuple. In that one, the production rules, it is a combination of terminals and non-terminals. So to derive a string from the production rules, we have to take the two steps we have to follow. In that one, we have to decide the non-terminal which is to be replaced. So to derive a input string from the production rules, first step what we have to do, we have to substitute the non-terminal symbols with the terminal symbols. That is the thing we have to follow. And here, before going to that, in the production rules, we have to follow the which step in the sense non-terminals, which non-terminal we have to decide to replace that. To replace the which non-terminal we have to decide first. And we have to decide the production rules by which the non-terminal will be replaced. And first step is we have to decide which non-terminal we have to replace. And after that, and in non-terminal place, which production rule we have to use is the second thing. Decide the production rule. So first one is we have to decide the non-terminal symbol, which non-terminal symbol we have to replace, and what is the replaced symbol with the production rule. So instead of this non-terminal symbol, which production rule we have to place in that production rule. And here these are the two steps we have to follow for the derivation of input string. And here we have the two options. So here in the derivation part, we have two options. One is the leftmost derivation and rightmost derivation. So let's move to the leftmost derivation and rightmost derivation. So what is meant by leftmost derivation? The leftmost derivation is obtained by applying the production to the leftmost variable in the each step. So here it is a production rules. Let me write a production rule. So this is just an example. So here the left hand side. So this is the left hand side and this is the right hand side. So here the right side is a combination of terminal and non-terminal. So in that one, first step what we have to do in the following step of derivation. we have to decide which non-terminal we have to replace. So here it is a non-terminal. In right hand side it is a non-terminal. So in this production rule, if I want AB, so AB is the input string. So, and what is the production rule in the sense? The production rules are A tends to AB and B tends to B. So these are the production rules. For these production rules, we are using the derivation part. So here in this first step, what we have to do, we have to decide which non-terminal we have to substitute. So this is the first step. We have decided B has to change or B has to replace that one. And here, and which production rules? Here we have two production rules, and which production rule we have to substitute. So here B tends to terminal is the production rule we have to substitute. So S tends to A and B. So B tends to B. So this is the second step which I followed for the derivation part. So first step, first non-terminal we have to decide, and which production rule we have to use in that production rules. So here it is a derivation part. And coming to the leftmost derivation. So here two types of derivations we are discussing. The first one is a leftmost derivation. So simple thing, and here we have to follow the step left hand side. So in the production rule, what we have to do in the sense, we have to convert the non-terminal from left hand to right hand. So that is the leftmost derivation. So these are the production rules. So let me write for this one a grammar. So G is equal to, so it is a combination, only E terminal is there. So E is the V, and what are the input symbols? A, comma B. These are the input symbols, and plus, minus and plus also. And production rules are this: E is equal to E plus E, E minus E, and A or B. And what is the starting state is E here. And these are the these are the grammar tuple, 4 tuple. And for this one, first leftmost derivation. So in leftmost derivation, first we have to take the start state E is equal to E plus E. So what is our input string is A minus, what is the input string? So A minus B plus A. So here in left hand side, so left hand side we have to replace. So here we have two things, one is left and right. So every time we have to change in the right hand side part only, not in the left hand side. So in the right hand side also we have the two terminals, one is left hand side and right hand side. So here if you replace this left hand side, this is the leftmost derivation. So from left hand we have to replace the non-terminal symbols, and the second step we have to replace that with the production rule. So here I am replacing this left hand side of E. So here E tends to, so here we have A minus B. So A minus B. Is there any production rule with the minus? We have to substitute. So here E tends to E minus E. So here next step is we have to substitute this E tends to E minus E, and next E. So same again we are writing this plus E, and next step is we have to follow the leftmost derivation. That is nothing but we have to convert that non-terminals to the terminal from the left hand side. So here is the leftmost non-terminal. So leftmost non-terminal, here according to our input string we have to use the production rule. So here E tends to A. We will take E tends to A, and here and remaining we will write same. And next is leftmost derivation, leftmost non-terminal is E. This E. So here according to our input string B we require. So where is the B? So here E tends to B. So we will write A minus B plus, and here next after this completion we go for the leftmost. So this is the last non-terminal we have to replace. So here E tends to B already there, and this E tends to, so according to our input string A requires, so E tends to A, and here A tends to A minus B plus A. So this is the input string what we got from the leftmost derivation. So here for the according to our derivation definition, so we require the non-terminal, which non-terminal we have to decide first. After that, according to our input string and according to our production rule, which production rule we have to substitute in that non-terminal place. So this is about the leftmost derivation. And for the same example, we will do the rightmost derivation also. So here, this for the same input string, for the same production rules, how to form a rightmost derivation. So here, in this one, first step E tends to, so here there is a starting state E. So here E tends to E minus E. Let me take E tends to E minus E. And here in the right hand side, rightmost derivation part, the right hand side of the non-terminal we have to replace first. And here E tends to, what is that? Already minus is there. What we require? The plus symbol. So instead of this E, we will replace E plus E. So E minus E plus E. And again, we have to follow the rightmost derivation. So here, what is the input string having in the last part? So E tends to A we require, and E minus E plus A. Instead of A, we are writing E. And after that, we follow this rightmost. What is the input symbol here? B. And here we will require E minus B plus A. And last one, E tends to A, and here A minus B plus A. So this is the input string what we got in the rightmost derivation. So this is about the rightmost derivation, and we will discuss more about this leftmost derivation and rightmost derivation with the examples. So here is another example. So derive the string ABB for leftmost derivation and rightmost derivation using CFG, context-free grammar. So what is this context-free grammar? Let me write. So here only production rules they have given. We have to write the production. We have to write the grammar for this one. So what is the grammar contains? So what are the non-terminal symbols? So S, A, B. And what are the terminal symbols? Small a, small b. And what are the production? These are the production rules. And what is the start symbol? S. S is the start symbol. So first step is we take the input string. According to the input string, we will form the leftmost derivation and rightmost derivation. So here we will take the production rule S tends to AB. So input string is A, B, B. So in the leftmost derivation, what terminal we have to decide, in the sense left hand side. So here the left hand side is A. So for this input string, what we require, 3 terminals are required. So for the A tends to AB, if you take this string, so if you take this production rule, so how it is? A tends to A, B. So A, capital B and B. Again we are writing. And here, and we already got B tends to B and B, B is there. So if you replace this SB, so leftmost is this one. So B tends to SB. And here, after substituting this SB and B, and instead of this S, we will write this epsilon. So we will replace. So left hand side. So here the leftmost, what are the non-terminals are there in the left hand side, we have to replace them. And here S tends to epsilon, and here A, epsilon B, capital B. So epsilon, if you remove epsilon B, and here instead of this B, what we have to replace? So here we already got this input string and we only require B. So for this one only we have to substitute, only we have only production rule, B tends to SB. So B tends to SB. So SB we will write, and same as it is, S tends to epsilon we have to substitute. So A, B, epsilon B. So finally we will get the input string. This is about the leftmost derivation. Leftmost derivation. And here for the same thing we will write the rightmost derivation. So here we will write the rightmost derivation. So for first step, start state, we have to take AB, and which in the left hand leftmost derivation we took A as a non-terminal and we have to replace that A terminal. And here in the right hand side of rightmost derivation, so B is there, according to our input string we have to change that. So S tends to AB. So B is only having the production rule, so B tends to SB we have. So SB. So and after this one, what we have to replace? The rightmost derivation. So S tends to epsilon we have to write. So here S tends to A, epsilon B. So here after this one we will get S tends to AB. And here only non-terminal is A. So here we have to substitute A tends to, we require two terminals. So two terminals we require, that is AB. So instead of AB we require, so A tends to only one production rule is there. So what is that? A tends to AB. And here we will write that A, B and B. And here we have to write the right, only one terminal is left. So one non-terminal left. We will replace that with the B tends to SB. And here S tends to, so SB is there, A, S, B. And S tends to, so SB, B. So we left this one. And here S tends to epsilon we have to substitute. So epsilon B, B. So finally we will get the string A, B, B for this production rule. So this is the rightmost derivation. So this is how we are deriving the input string from the given production rules. So this is about the leftmost derivation and rightmost derivation for the given grammar. And next example. So derive the string. Here the length of the string is, we have taken 8 bit. So 8, length is 8. So for this kind of input string, how to do a derivation, and that is also rightmost and leftmost derivation. So first we will draw the, we will do the grammar for this one. What is the grammar contains? We have to write the non-terminal sets. So non-terminal sets A, B. So these are the non-terminals and terminals are A, B. And what are the production rules? We already have. And what is the start state? So these are the 4 tuple, and this is about the grammar for this given production rules. And here we will take this, we will write the input string. So what is the input string here? A, B, B, A, B, B, A. So this is the input string we have to take. And first step is we have to decide which production rule. So the starting state, it is having the 2 production rules. So we will take that S tends to A, B. So here we will write this leftmost and rightmost. So here this is about the left and this is about the right. We have to rightmost derivation and leftmost derivation. And here we will take the input string in production rule S tends to AB. For this one, left hand side there is a terminal is there. So only only one non-terminal symbol is there. So we have to substitute that non-terminal. So B tends to. So according to our input string, we require A already there and we require A. So is there a production rule with the A? Another A. Terminal B, B. So here we will substitute this A. Already A is there and B, B. So in this one, leftmost non-terminal is this B. So here we have to substitute according to the next. We have already B. So if you replace this B with this, we will get the B. And here what is the next step? We have to take the input string. So here we require B, B. We will write this S tends to A, B, and we have only next non-terminal is this B. So here we will write, instead of this B, we will write BS. With this input string is finished. So BS we will write. So S tends to A, B, B, S. So instead of this B, we are writing this BS. And here only non-terminal is right hand side, that is only one non-terminal is there. For this S, what we have to do? So according to our input string, we require, already we got the 4 length and we require AB. So here is there any kind of this production rule? So A, B. So here A, B, B, and we require A, B. We will substitute. And here again one production rule B is there. So here we got this A also and we require this 3 length. So that is also with the B input string. B terminal. So B tends to B, S we will take. So small b, S. So here A, B, B, S. So for this one S, instead of S we will write S tends to B. Next input string is having the B. So B, A. So here S tends to A. So we will write this A, B, B, and we will substitute this B, A. So what we have to do, A tends to, we require the last input symbol A. So we will substitute this A tends to A. So we got the input string from this production rule. So this is how we are getting the leftmost derivation. So leftmost derivation, we will get the input string. Like that, we will also convert that, we will also derive the string from the rightmost derivation part with this production rule. So let me take S tends to. So S tends to AB, we will write. And here, so only one terminal is there. So we will substitute this non-terminal is there. So B tends to what we require for the non-terminal. So B tends to A, B, B. We will take this one. So A, B, B. And here if you observe, we started in leftmost derivation, we started this B. So in the rightmost derivation, we have to replace this non-terminal. And here this B tends to which production rule we have to take? BS. So instead of this one, we will replace A, B and this BS. So here what is the rightmost non-terminal is S. So here we have to substitute this S tends to BA. So here what we will get? So here S tends to A, B and BA. And here the rightmost terminal in non-terminal is A. So here what we will write? A tends to. So what is the requirement here? A tends to A. If you replace this A we will satisfy the last input string of BBA. So here we will write AA, B, BB, A. And next one is we require only have the non-terminal B. So here we will write this B, how many input string of BBA we require. So we already have AA and we have to get the BBA. So for this one, what is the BBA? So instead of this B, so we will write BS. So here AA, B, S, B, B, A. So again we have BA, we require BA. So for this one, for S tends to BA, if you substitute this one, we will get the input string as this B, B, A, B, B, A. And finally, if you replace A with terminal A, we will get the input string as it is B, B, A. So this is about the rightmost derivation. So this is about the input string, what we have for this input string, how to derive the leftmost derivation and rightmost derivation for the given grammar. And next example. So we will take the input string. Let me write. This is the input string 100 101. For this input string, what is the grammar? For this context-free grammar, what is the grammar? So for what is the grammar in the sense, we have the non-terminal set S, A, B. And what is the terminals? So terminals are 0, 1. And next, so these are the production rules and S is the start state. So here we will divide this leftmost and rightmost for the input string 00101. So this is the input string and leftmost derivation, rightmost derivation. Rightmost derivation. So here we will take the first production rule S tends to A and B. And we have only one production rule for the start state. So with that start state only we have to derive the equation. And S tends to A, 1, B. And here the leftmost derivation. So in the leftmost derivation we have to substitute the leftmost non-terminal. So leftmost non-terminal is A. So what is our input string is 0, 1, 0, 0, 1, 0, 1. So with the array non-terminal, what is the production rule? We have only 0A and terminal. So we will substitute A tends to 0A. So if you write this substitution production rule, and here according to our input string, what we require? Another 0. 0 we require. And leftmost non-terminal, that is also we have to replace non-terminal leftmost. So again we will write A. And here A, 0, A, 1, B. And here the leftmost non-terminal is A. And if you substitute this A tends to epsilon, we will write 0, 0, epsilon 1, B we have. So 0, 0, 1, B. So this is the non-terminal left. So instead of what is the input string? We have 0, 1 we require. So for this one, we will write B tends to 0, B. We will substitute this 0, B. And the leftmost, after this one, according to our 1, we require 1, B. S tends to 1, B. So in this one, 0, 0, 1, 0, 1, B we have. So we already have this input string, and if you replace this B with the epsilon, we will get the input symbol. So this is about the leftmost derivation. So we have the leftmost derivation and with the input string 0010. So like that we will also convert this to a rightmost derivation. So with the start state we have start production rule we have to take, and So in the leftmost derivation, where we have to start, we have to replace the non-terminal in the right hand side. So non-terminal right hand side is B. According to the B, we already there. So if you substitute this, B tends to, so B tends to 0 B. So here A 1 0 B. So here we already have 1 0 1 0. We require B. B tends to right hand side. We have to substitute 1 B. If you substitute this one, A 1 0 1 B. So here B tends to epsilon. So 1 A 0 1 epsilon. And after this, we have only one non-terminal. So we have to replace, and again we will get the A 0 0. So we already have 1 0 1. What we require? We require 0 A. We will substitute this A with 0 A 1 0 1 and all epsilon. And here what is the only non-terminal we have? We will substitute A tends to 0 A. So 0 0 A, again A 1 0 1. So if you substitute A tends to epsilon, we will get the input string. So this is the rightmost derivation. So we got the input string. For the production rules, this is how we have to derive the leftmost derivation and rightmost derivation for the given input string. So these are the examples of leftmost and rightmost derivation in the context-free grammar. And these are the references where the examples are taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.